Assalamualaikum. My name is Nur Shafina binti Rosli. My metric number is D2021 1099-263.
Assalamualaikum and hi! My name is Nur Nasha binti Hatta and my matrix number is D2021 1099-265.
So hi, my name is Nur Suhaida binti Muhammad Ali with matric number D201820866695.
Hi, good morning class. Today, we want to learning about group 50 elements in periodic table. So stay focused and let's start. Group 15, also known as the Pendidikan or nitrogen family. The P block elements are put to the right hand side of the periodic table. There are 5 elements in group 15. The element consists of nitrogen, phosphorus, arsenic, antimony, and bismuth. So class, how to remember the group 15 elements? No public assistance, stay back with biscuit. So, I give you 5 seconds to memorize these tricks.
5, 4, 3, 2, 1.
Let's see the first element. The first element known as nitrogen. Nitrogen is a colorless gas and a non-metal. The combustion of fossil fuel such as coal and oil is the major source of atmospheric deposition. Do you know the derived of name is from Greek known as nitron engis, meaning niter forming. Nitrogen in the form of ammonium chloride is known to alchemists as sal ammonium. It was manufactured in Egypt by heating a mixture of dung, salt, and urine. The first person to suggest this was a young Daniel Rutherford. As we know, the nitrogen is used in fertilizers, but the other application, nitrogen is used in dyes, nylon, and nitric acid. And the most surprised us, nitrogen is used in explosion. The second element is phosphorus. Dairy, red meat, seafood, and nuts are called phosphorus, but it was known as inorganic phosphorus. Do you know phosphorus was first made by Hermann Brett in 1669 when he evaporated and heat the urine, then he collect by condense it in water. As a common application, phosphate is used in fertilizers industry. But the unit of phosphorus is used in matchbox, which is the heat is generated by friction. Phosphates also enhance to cleaning power in detergent, which is very helpful. However, this application already banned and causes major environmental hazards. The third element is arsenic. They are metalloid. An organic arsenic compound is soils, sediments, and groundwater. It is occur naturally. This compound was discovered by Albertus Magnus. During Ming Dynasty, they noted the toxicity associated in arsenic compound. Arsenic is known as poison to human. Contaminated water is used in drinking or food is the greatest threat to public health from arsenic. Long-term exposure to arsenic can cause cancer or skin lesion. Have you ever thought that arsenic is using in ammunition manufacturing. It helps to harden and rounder the bullets. The fourth element in group 15 is antimony. They are metalloids. The source of this element is from soil. Nicolas Lemery, a French chemist, was the first person study about arsenic and its compound. The black form of the pigment, which occur naturally as the mineral signet, was used as mascara and known as coal. The common use of antimony is in battery. This element harnesses lead alloy for battery. And other than that, the antimony is used as a semiconductor in infrared detectors. Last element is bismuth. This element is a typical metal. The source of this element is from copper, tin, silver, and gold. The common application of bismuth is used in fire extinguisher and electric fields. But did you expect that antimony is used in medicine for heartburn and acid reflux, and it also used in cosmetics. It used as a stabilizing agent. I think that's all from me. Let's answer some quiz and good luck.
Now, let's learn about physical properties of group 15 elements. Nitrogen is a diatomic gas, while the rest elements of group 15 are solid in nature. Next is melting points. Going down the group, melting points increase due to increase in atomic size. However, the unexpected decrease in melting points of Sp and Bi because their tendency of forming 3 covalent bonds instead of 5 covalent bonds due to inner pair effect. What is inner pair effect? Inner pair effect refers to the valence electron in s orbitals that penetrate to the nucleus better than p orbitals. As a result, they are more tightly bound to the nucleus and less able to participate in bond formations. Continue to the explanation of melting points. As a result, the attraction among the atoms are weak, hence the melting points are lower. Bi has weaker interatomic forces than Sp because Bi has larger atomic size than Sp. Therefore, Bi has lower melting points than Sp. Thirdly is boiling points. Going down the group, boiling points increase due to increase in atomic size. Fourthly is metallic character. Group 15 elements are less metallic than group 14 elements. This is due to a smaller atomic size and higher nuclear charge of group 15 elements than group 14 elements. But going down the group of 15 elements, metallic characters increase due to increase in atomic size. Nitrogen and phosphorus are non-metal, while arsenic and antimony is metalloids, and bismuth are metal. Fifthly is allotrophy. Except nitrogen and bismuth, all other elements shows allotrophy. Phosphorus exists as white, black, and red, while arsenic exists as yellow, gray, and black, and antimony exists as yellow and gray allotrophic forms. 6 is electronegativity. Group 15 elements has more electronegativity than group 14 elements. This is due to smaller atomic size and higher nuclear charge of group 15 elements compared to group 14 elements. But going down the group, electronegativity of group 15 elements decrease due to increase in atomic size and shielding effects of inner electron shells. Lastly is atomic radii. Group 15 elements has smaller atomic radii than group 14 elements. This is due to increase in effective nuclear charge of group 15 elements compared to group 14 elements. But going down the group 15 elements, atomic radii increase due to the addition of new number of shells at each element.
Hi, I'm Nur Suhaida binti Muhammad Ali, and I'm going to teach you on chemical behavior or chemical properties of group 15. So let's recall on what you know. Chemical behavior of group 15 are heavily influenced by their electron valence, the electron in the outermost shell. Let's recall on what Noshasha has said before. The appearance of group 15 as going down the group changes from non-metal to metal. Let's proceed on the first chemical behavior of group 15. Group 15 has 5 electron valence, so they require 3 more electrons to achieve octave electron to become stable. So they achieve this stability through covalent bond or ionic bond. Commonly, group 15 form covalent bond with other atom to become an ion, except for bismuth. Sometimes bismuth become cation by losing 3 electrons. For example, bismuth trifluoride. Now let's move on to the second chemical behavior of group 15. As going down the group, the oxidation number become lower, but they increase in basicity. This is due to the ionic properties to interact with oxygen or react with oxygen and hydrogen to become hydroxide. But nitrogen has one uniqueness principle where its oxidation number varied from positive 3 to negative 3. Now, let's go with the third one. All group 15 react with hydrogen to become hydrides. All hydrides from group 15 are poisonous, highly reactive and unstable, except for ammonia. Ammonia can be produced naturally from our body process and through industry by Haber process. Ammonia is the first degree hydride as low in mass but high melting and boiling point. This is due to its short-term bond with hydrogen. Second degree hydrazine can be produced by oxidized ammonia to become hydrazine. Hydrazine are highly poisonous and toxic for humans. So that's why in laboratory 4 we learned that hydrazine cannot be used by its own but be used in the form of salt. So what can we learn from hydrides about group 15 is, as going down the group, the length between hydrogen and the element of group 15 are getting longer. Thus, this decreasing the strength of the hydrogen bond, making easier for the bond to be break by heat. Now, for the last chemical behavior of group 15. Group 15 can react with halogen to become a halide in the form of trihalide or pentahalide. If there are more halogen in a group 15 compound, it will decrease the stability of the compound, except for nitrogen trifluoride. This is because of the low energy between the bond of fluorine with fluorine. Group 15 halide can react with water to produce hydrogen and oxoacid. And this is the generic formula for the reaction. So now let's take a break. Now let's proceed on the effect of group 15. I will be focusing on the effects of group 15 on humans. In 2001, an arsenic-contaminated river in Bangladesh killed 9,000 people. The cause of death is due to the vital organ destruction. Did you remember what Noshafina has said? Phosphorus can be found in our dairy product. So high content of phosphorus in human blood or human body can induce high rapid growth of cancer cells. A high concentration of ammonia can be toxic. a byproduct of ammonia, which is ammonium nitrate, or known as to be fertilizer, can be highly explosive if it's stored in a large amount. Remember the incident happened in Beirut, Lebanon? Nitrogen can be a feeding source for nitrogen fixation in legumes, so the legumes will provide food for us. The usage of bismuth in cosmetics helps humans to become pretty and gain confidence.
Now, let's get to know about the effects of group 15 elements towards the plants and animals. Phosphorus and nitrogen support the growth of algae and aquatic plants, which provides food and habitat to the fish, shellfish, and small organisms that live in the water. But too much phosphorus and nitrogen will cause the algae to grow faster than ecosystem can handle. Apart from that, excess nitrogen at atmosphere can produce pollutants such as ammonia and ozone, which can alter the growth of plants. When excess nitrogen comes to the earth from atmosphere, it can harm the health of forests, soils, and waterways. Other than that is antimony. Antimony will mainly pollute soils. Through groundwaters, it can travel to other locations and surface waters. Relatively high levels of antimony may kill small animals. Lastly is arsenic. Arsenic is toxic towards the plants and animals. This is due to the fact that it can cause cell death through oxidative stress or by interfering the cell's ability to produce ATP.